Pretty much every moment of every day, billions of us are doing something online, streaming, messaging, searching for things. And we have this easy name for it, right? We call it the cloud. It makes it sound like it all just happens somewhere up in the sky. But the truth is, our entire digital life is sitting inside very real and incredibly powerful buildings right here on the ground. So that begs the question, if it's not floating around up there, where does the internet actually live? Where does all this data go, and where does all the processing happen? Well, the answer is a whole lot more industrial and a lot less magical than the name cloud would have you believe. The internet lives right here, inside these massive, often totally windowless buildings we call data centers. Honestly, you should think of them as the real factories of our digital age. They are the true foundation for almost everything we do online. So, to really get a grip on how our digital world works, we've got to look inside these places. We need to see what makes them tick from a simple click to the actual machine that answers the call. Okay, so what is a data center at its core? It's really just a highly specialized building. Its only job is to create the perfect environment with constant power, cooling, and connectivity for thousands and thousands of computers, which we call servers, to run 24/7 without a single interruption. And these servers, they're the workhorses of the internet. I mean, every single time you check an email, stream a show, or use an app on your phone, you're actually communicating with servers just like these. They're the ones storing the data and running the software that makes everything work. But here's the thing, the computers are really just one piece of the puzzle. For every single one of those servers, there's a whole ecosystem of heavy-duty industrial equipment working in the background just to keep it online. Think of all this as the life support system for the servers. If any one of these components fails, whether it's the power grid, the cooling system, or anything else, it could cause a huge shutdown, knocking websites and services offline for millions of people. And that brings us to the first massive challenge of running a data center. You have to feed its constant, absolutely enormous appetite for electricity. Let that sink in for a second. The amount of energy it takes to run these servers non-stop is so huge that a single one of these buildings can draw as much power as a small city, and that power can never, ever go out. So to guarantee that 100% uptime, data centers use a really clever multi-layered plan. If the main power grid fails, a giant bank of batteries called a UPS takes over instantly. It happens so fast, the computers don't even notice. This gives just enough time for massive diesel generators to automatically fire up and start powering the entire facility. And we're not talking about a short-term fix here. Most of these places keep enough fuel on site to run completely off the grid for days at a time. This makes sure that even during a huge regional blackout, your services stay online. Now, all of that electricity being used creates another major headache, a mind-boggling amount of waste heat. And managing all that heat is every bit as critical as managing the power. This comparison really puts it into perspective, doesn't it? Now, imagine that heat multiplied by thousands of racks. You're basically dealing with a thermal challenge on the scale of an industrial furnace. Without constant, powerful cooling, those servers would overheat and die in just a few minutes. So how do they do it? Well, the main solution is about managing airflow with incredible precision. The whole layout is designed with dedicated cold aisles that pump chilled air into the front of the servers and hot aisles that capture all the hot exhaust coming out the back. That hot air then gets whisked away to be cooled down, and the cycle just keeps going. Okay, so with the power and cooling handled, let's follow the journey of your data. We're going to trace how a single request travels from your screen to one of these buildings and all the way back, all in literally the blink of an eye. Let's use a simple, everyday example. You hit play on a video. What's the actual physical journey that your request takes to get that content from a server farm onto your screen? The whole process is incredibly fast. Your request shoots through a bunch of networks to get to the right data center. Inside, it's directed to the exact server that has the video file you want. That server finds the data and sends it right back across the internet to you, and this whole round trip usually takes just milliseconds. Of course, it's not quite as simple as your request going to just one server. To handle millions of us all at once, data centers use something called load balancing. It's a smart system that spreads out all the incoming requests across lots of different servers. This keeps any single machine from getting overloaded, and it makes the whole system way faster and more reliable. But, this amazing speed and reliability, it comes at a cost. The physical infrastructure that makes the cloud possible is incredibly demanding and has a pretty big footprint on our planet's resources.
To keep these places humming requires a constant, massive flow of resources. And that's not just the huge amounts of electricity we talked about. It's also water for cooling systems, huge pieces of land to build on, and a never-ending cycle of manufacturing and replacing all that computer hardware. When you add it all up, the collective energy use of data centers is enormous. And as our demand for digital services keeps growing, especially with things like AI, so does their demand for power. That's why energy efficiency has become one of the biggest challenges for the entire industry.
So at the end of the day, the cloud isn't some abstract concept at all. It has a physical address. It's a worldwide network of very real, very tangible, and very power-hungry buildings that form the true foundation of our digital world.
And why does all this matter? Well, because almost every part of modern life now depends on these buildings working perfectly, all the time. Our banking systems, our social networks, entertainment, government services. A failure in this infrastructure would have immediate and widespread consequences for all of us. So the next time you use an app or watch a video, just take a second to remember the journey that data is taking. It isn't floating up in some magical cloud. It's racing to a very real building, a powerful and complex data center that's quietly serving as the hidden physical backbone of our entire modern world.